This particular video, we're going to talk about the different types of data, okay? The types of data that we're going to talk are quantitative and qualitative. Another term for qualitative data is categorical. Now, when you look at data, how can you tell which is which? Well, quantitative, always, the root of the word quantitative is quantities, and a quantity is a how many or a how much. So they always involve numbers. So some examples of quantitative data are how many home runs did someone hit, someone's height, someone's weight, the number of hours of sleep, or one of my personal favorites, how many fish you caught. Qualitative or categorical data does not involve numbers or quantities. It involves a particular quality, hence the name qualitative. Something that can be categorized. For example, what's your favorite color? What's your favorite music? Favorite animal? Hair color? That kind of thing. So that's your basic difference between qualitative and quantitative data. Now let's dig a little deeper. Quantitative data is one that contains numerical values and uses a range or a spread of those numerical data, It is subclassified as discrete and continuous data. So some type is called discrete, some type is called continuous. So you have this broad category called quantitative data. It's things that have to do with numbers. And in some cases, you can only get discrete, and in other cases, you get continuous data. Now, what do we mean between discrete and continuous? Well, discrete data contains finite values that have nothing in between, as against continuous data, which is something that can be measured that includes fractions and decimals. Let's give you some examples. If you have quantitative data, like a number of workers in a company, you could divide every one of the, can you divide the workers into two parts? I certainly hope not. What kind of a job is that? Because the numbers of workers can only be like 2 workers, 10 workers, 12 workers, 15 workers. It's discrete data. It's a whole number amount. In other words, discrete data is a count that involves integers. Only a limited number of values is possible. Discrete data values cannot be subdivided into parts. Like we said, you can't have that half a person working for you. For example, the number of children in a school is discrete data. You can count whole individuals. You can't count 1.5 kids unless it's a really, really bad school you don't want your kids going to and the custodian is about to make some kind of horror movie, okay? Discrete data, some key characteristics. You can always count the data. It's usually units counted in whole numbers. The values cannot be divided into smaller pieces and add additional meanings. You can't have a half a kid. That kind of thing. You cannot measure the data. By nature, discrete data cannot be measured at all. For example, you can measure your weight with the help of a scale. So your weight is not a discrete data. And the reason for that is because, okay, maybe you weigh 230 pounds, but you could also weigh 230 and a half, 230 and a quarter, 230 and 3/8, and so on. It also has a limited number of possible values. It's finite. For example, it could be the days of the month. It could be the number of times that you did something, things like that. So discrete data, whole numbers, and it can't be divided into smaller pieces. Whole numbers cannot be divided into smaller pieces. Some examples of discrete data: number of students in a class, the number of workers in a company, number of parts damaged during transportation. Notice, you don't get fractional answers here. Either a part is damaged or it is not. Kind of like hand grenades. Either it blows up or it doesn't. Shoe sizes. The number of languages an individual speaks. You can't speak a part of a language. You can speak 3 languages or 33, but you're not speaking 7 1/4 languages. The number of home runs hit in a baseball game or in a season. The number of test questions you answered correctly. Again, all things that are countable. Discrete data is countable. Instruments on a shelf. The number of siblings a randomly selected individual has. All examples of discrete, that is countable, whole number, cannot be subdivided data. Continuous data, what about that? Well, let's talk about some definitions, some examples, and a little explanation. The 2 types of quantitative data, numerical data, are discrete and continuous. Continuous data is considered to be the opposite of discrete data. Let's see the definition. Continuous data is information that could be meaningfully divided into finer levels. Remember, we said that weight was not discrete because it could be 230 and a half, 230 and a quarter, 230 and 3/8. That is a finer interval. It can be measured on a scale or in a continuum, and it can have almost any numeric value. For example, you can measure your height at very precise scales, meters, centimeters, millimeters, etc. You can record continuous data at so many different measurements, width, temperature, time, etc. This is where the key difference with discrete data lies. Discrete data, whole numbers cannot be broken down. Continuous data can be broken down and does not need to be a whole number. In general, continuous variables are not counted. They can be subdivided into smaller and smaller pieces, and those smaller pieces have additional meaning. The continuous data is measurable. For example, you can step on a scale and check your weight. You can check your height. You measure those things. It has an infinite number of possibilities within an interval. For example, I know this, we haven't talked about the concept of infinity yet, but between, let's say, 100 and 101, someone weighs in there, there really are an infinite amount of numbers, because if you think it's 100 and a half, well, I could take half of that and get 100 and a quarter. But I could take half of that and 100, and I can get 100 and an eighth, and then 100 and a 16th, and 100 and a 32nd. And you could just keep going and going and going forever. You can always find another number in there. So it's continuous data. There are an infinite number of possibilities within an interval. Continuous data is graphically displayed by histograms. Okay, we'll talk a lot about that when we get to a whole day of histogram work. And in comparison to discrete data, continuous data give a much better sense of the variation that is present. The reason it gives you a better sense is because it's a little more exact in its detail. Some examples of continuous data: the amount of time required to complete a project, the height of children, the amount of time it takes to sell shoes. Notice with all of these things, continuous data, because you can express your result as more than just whole numbers. It could be 2.5 minutes. It can be 3.5 weeks, 5 feet 2.25 inches, like that. The amount of rain in inches that falls in a storm. I just read 2 weather forecasts for tonight into tomorrow. One said we'll get a 1/2 inch. One said we'll get a whole inch. That's continuous data. It can be anything in between. Square footage of a 2-bedroom house, because a square foot doesn't have to be a whole number. It can be a part of a number. The weight of a truck, the speed of cars. You're going 50.25 miles per hour. The time you wake up. It's not 8 o'clock or 9 o'clock or 10 o'clock. That would be discrete data. But you could wake up at 9:30. Okay? All right. So at this point, I'm going to stop working on this, and we're going to get into some applications. Okay?